Hey, Anatomy students, this is Mr. Yance again, and this is chapter 7 and 8, and you'll see at the top of the slide here is test 1. The skeletal system is so big, I'm going to split it up into 3 parts. So we'll have 3 smaller tests instead of 1 huge test. So this one's really heavy on diagrams, so those color sheets that you're working on, that's mainly what the test is over. It's like 65 questions, and 55 of them are off those diagrams. And there's only 10 questions on all numbers, which you're going to see coming up here. Well, mostly numbers, I shouldn't say all, but the test will be 10 multiple choice, and then the rest is going to be diagrams. So let's jump right in. So the skeletal system, the first 2 functions of the skeletal system is pretty obvious, support and protection. So when you think of your bones, you're thinking of the framework, the protecting vital organs, the rib cage, the vertebrae, the skull, pretty self-explanatory. I don't think we think about movement as much. Mainly when you think of movement, you think of muscles, but those muscles have to have anchors, and they have to have something to move. So bones serve as levers and anchors for all the muscle movements. So very big in the area of movement. And then the last 2 are ones that people don't think of at all. That's mineral reservoir. We store a lot of calcium and phosphorus and other minerals in the bones. And hemopoiesis, which is the fancy word for blood cell formation. We call the bone marrow myeloid tissue, and that's where our blood cells come from that we have to replace all the time. Now, you're going to see at the bottom of this slide, when you're a child and you're growing, your metabolism's through the roof, almost all your bones contain marrow, red active marrow producing blood cells. But when you get older, we don't need all that marrow. We're just maintaining. So once you become an adult, which most of you are at that point, then our red marrow exists in our sternum, our chest, our spinal column, the vertebrae, the base of the skull, the humerus, the upper arm, and your femur, which is your thigh area. That's the only place we have red marrow, and that's where we'll keep that red marrow, the rest of our lives in those strategic places. What happens to the rest of it? That's a good question, because you don't want to just lose it, because then those bones will become hollow, because the bone marrow is in the center. I'll show you a picture in a sec. Is in the center of those bones, and if we lose that, then we have a hollow bone in the inside. So we replace it with that adipose tissue we talked about last chapter, fat tissue. We pack that in there, and that still gives our bones some protection and some stability, so that we don't have hollow bones as we grow and get older, and we don't use that red marrow so much. So that's the 5 main functions. 2 pretty obvious, and 3 you got to think a little bit about. But that's what the skeletal system does for us. Now, this next slide, for no better way of actually, titling it, I just call it facts about bones. So I just thought I might throw in some facts, and I don't know what happened to my wonderful video cam there. Hang on a second. Let's see if I can get that fixed. There we go. I'm back. I don't know if that's good or bad. If I get lost again, we may just say forget it. You can just hear my voice. You don't need to see me anyway. But some interesting facts about bones. About 50% of your bones are found in your hands and feet. You'll find that out from the diagrams. A lot of wrist bones, a lot of ankle bones, because of how we move and how we grasp things and that type of thing. So, more than 50% of those bones are in the hands and feet, which is kind of interesting. A newborn baby, and I've seen all over the place on numbers, so I'm just going to give you a range. Anywhere between 270 and 350, good test question, by the way. When we're a newborn baby, our bones are all separated. As we get older, they fuse, especially our vertebrae, our hip, our skull, and eventually we get down to 206 is what we'll end up with and have that the rest of our life. So 206 in an adult skeleton, newborn is going to have a ton more. Number 3 is kind of interesting. You always see a plus symbol a lot of times on internet sites and diagrams when we're talking about the skeletal system, and people always ask, what's the plus for? Is it 206 or not? The plus symbol is, there's little things called sesamoid bones. I'll show you a picture in a little bit. Well, I'll show you right now. You can see, and there goes my video again. I don't know what's going on with that. You can see right here that these are little bone chip-like areas. And that's basically places where tendons turn a corner. So if a tendon turns a corner, that exposes that bone to a lot of friction because tendons anchor your muscles to your bones. And that's just the way the skeletal system protects the bones in your joints. So that's where they're not true bones, they're just little pieces of bones, but we have to account for them. So instead of giving them a official classification on the 206, we just put a plus symbol. About every 10 years, your body replaces the entire skeleton. And there's a good video about that. I'm not going to take time to show you now. I did put these slides are on Google Classroom, so you can because I've already went through all this with my classes. So you can look there and play the video if you like. If you don't want to, that's fine too. But that kind of explains 10 years. It's not like we shed our skeleton like an insect, but every 10 years or so, we do replace our entire skeleton. And 97%, going back to one of the functions of the skeletal system, which is a storage depot for minerals, 97% of your body's calcium is stored in your bones. You might want to take note of that. That's a test question too. So a lot of test questions come from this slide. The 50%, the 206, the 97%, the baby 270 to 350. There's like 4 of the 10 multiple choice right there. So kind of take note of that. And we will, that's pretty much what we'll test you over as far as multiple choice goes. All right, what I mainly want to go over is I want to get this in today, and then tomorrow I'll start in with the going through your diagrams. So try to get those diagrams done and so you can reference them for study. Now, don't get freaked out. I'm going to give my test to my regular class on Wednesday. They're a couple days ahead of you on notes. So I'm going to give you guys your test on Friday. So we'll just kind of make it, the time you usually have class. I will send you an email and a code, and then I'll check in with you on Google Classroom. So I want you to take it in the morning of Friday. And then Wednesday or Friday afternoon when we do our normal Google Meet, then I will check in with you and make sure you've taken that test. So we'll get this test in. This is the new 6 weeks. Some of you were here for Google Meet, some of you weren't. We're just combining the 2 6 weeks together, so a little bit different than what we normally do. So don't get freaked out when you say, "Oh, test Wednesday." We're not even through notes yet. I'm lagging you behind just a tad, so we will get caught up hopefully tomorrow, or we'll get caught up Wednesday, and then we'll take our test Friday. All right, and I'll have the review game on there, and actually it's a Jeopardy game. I'll put that on there. You can look at it too. All right, okay. So let's kind of go about what types of bones we have. There are 4 types of bones, and all the bones kind of fall into one of those 4 categories. So 3 are pretty obvious, and 4 is a catch-all group. So if it doesn't fit in to these 3 categories, then we throw it into a catch-all group in the end. So I just mentioned some of them on this slide. There's more than that, but we got long bones, pretty self-explanatory. Your femur, think of how long it is, your upper thigh, the tibia and fibula, which is your lower leg, ulnar radius on your arm. Humerus, ulnar radius are all the arm bones. Long bones, okay? Nothing more to it than that. Short bones are the wrist, really tiny bones, your ankles, carpals and tarsals, we call them. And flat bones are really not flat. They kind of have a curvature to them, especially your skull, frontal, parietal, occipital, temporal. Those first 4 are all skull bones. Your ribs are not round. A lot of people think they are. They're flat. The scapula and the patella, which is your kneecap, and your shoulder blade, okay? So let's say they don't fit into those nice groupings. Okay, I understand, long, short, flat. Why if they don't fit into there? Then we throw them in the catch-all group, which is the irregular bones. So if they don't fit nicely into one of those other categories, then we throw them in here. Think of your vertebrae. They go all over the place. Sphenoid, ethmoid, those are in your face. Your mandible, your jaw, kind of weird shaped. Face bones, like your zygomatic, your cheeks, kind of a weird one. Your ear bones. Innominate, your hips, probably the best one of all time. So that's pretty much what we do. Now understand, that doesn't have a lot of significance. Why do we care if a bone's long, short, irregular? Does that really matter? It doesn't really matter when you're looking at a complete full skeleton. But let's say, I'm not trying to be morbid, but let's say there's a crime scene and we find, a shallow grave and there's just bones scattered everywhere. Okay, so when you're picking up those bones and analyzing them and trying to determine, is this a human? Is this a person that got killed or whatever? Then these become really important. I had an anatomy teacher in college that was very, to kind of emphasize this, he would actually bring in a paper sack of a disarticulated skeleton, which means that they're in pieces, and he just whip out a bone and say, "What is this bone?" And you talk about difficult. That's hard to do when you can't see where it's attached to a skeleton. And that's when you have to understand, oh, irregular, short, long, flat. That's where you start. And you're like, okay, that reduces my field. Now I can start looking at it and figuring out what it is. I'm not going to do that to you guys. Don't freak out. But that is something that is important, especially in forensic science and when you're looking at just pieces of a skeleton instead of the whole skeleton. All right. Okay, so I'm going to talk about this next slide. We'll save that for tomorrow, and hopefully you get out your color sheets. I'll have some pictures of them on here too, and we'll start breaking the skull down into all the bones so you know all 206. And we will take our test Friday, not Wednesday. All right. Hey, have a good day. We'll talk to you later.